Today, we're looking at Leetcode 225, implement a stack using queues. Now, this is a pretty common question. I believe it's on the 150, I'm not sure, but I have seen this question asked in an interview before. So this is a great question. It's related to stacks and queues. But basically, in this problem, we want to implement a LIFO, which is a last in, first out stack using only two queues. And we want to support all the standard functions of a normal stack, such as push, top, pop, and empty. So in that case, we're going to be pushing to our stack. We're going to be looking at the item that is at the top. We're going to be popping or removing that item, and then empty will basically just return a Boolean, true or false, if the stack is empty or not. Of course, I think it's worthwhile to mention that we could very easily, we could just use an array. We could say stack equals like an array. And then using just the array, we could do something like pop, and then we could say for like top, we could do something like stack dot length or stack, 0 would give us the first item. The reason why we want to use two queues is because, well, number one, the question or the problem requires that, but more so, one of the constraints is that we can't use pop. So this stack.pop would fail like the validation. So we need to use like a shift, which would remove an item from the back or the beginning of an array. And then also, I was wondering, why do they even ask this question? Well, this is actually just a question that is good to just test your knowledge of stacks and queues. And so just understand some of the nuances. There is a related question, which is the opposite of this, which is implement a queue using two stacks. So such that like a stack is a last in, first out. So the last item in will be the first out. Like it's just like stacking plates or like someone getting into an elevator. Typically like the last person to get in will be the first one to, leave the elevator. And so the queue would be the opposite of that, which is a FIFO, first in, first out. And just to kind of help with our visualization, I've got a little visualization of how this is going to work. We're going to use two queues. So we do have Q1 and Q2. And we're going to go about, what we're going to do is we're going to push initially all of the operations we're going to be doing, such as, top, which is usually called like peak, or looking at the, if it's empty or popping off the stack. We're actually going to be using our first queue. So Q2 is really, it's almost like a temporary queue where we can manipulate items, make sure we're going to empty it out and push everything to Q2 in a reverse order. But Q2 is sort of like a temporary holding place so that we can manipulate things and make sure that we are handling the first added item in an appropriate manner. So as we see here, so let's imagine that we first push A. And then let's go to the next step. We're going to look at Q1. It's empty, so there's no elements to move. At this point, we're going to do a swap. And you're going to see in the code, we're going to use a destructuring to swap all the elements from Q2 into Q1. So now Q2 is empty and ready to receive another element. So here we can just say next, all right, B. And we want the last one in to be the first one out. So if we didn't have two queues, the problem here would be that A, because push adds to the end, the top of our data structure, which is a stack, would actually be A, but we want A to be at the bottom. So watch this. Now we've got A at the bottom because we've used Q2 as a temporary area so that any newly pushed item can actually be at the top. then we swap again. You'll see this in the code we're going to write, but here it's going to swap. So if I hit next, it basically moves everything over and preserves it in the order that we want, which is we want the last one in, the first one to be out, which is B, which is the last one we added. And we would proceed to do the same thing with C, B, A, swaps over. Q2 is empty to receive D. We would add all these and then swap it over. So again, look at D is the last one we added. C is the last one we added before D, and so on and so forth. So all we're really doing is we're basically making sure that it's the opposite of how a queue would normally behave, especially because we're using push and pop. But in our implementation, you're going to see that we actually don't even use pop, because again, we can't use pop. We can't use any of the normal stack functions. So let's go ahead and start with defining our stack. We could use a class for this, like an ES6 class, but for now, we're just going to use like a constructor function, or just like a function in our standard JavaScript. So we define Q1 as an empty array. Q2 is going to be also an empty array. From here, let's go ahead and implement. We're going to say prototype dot push. Maybe I'll do a follow-up video of using TypeScript and maybe some ES6 classes, so this looks a lot nicer. But for now, we'll just do it really simple. We've got our item to add, and we're going to just say this dot Q2 dot push item. Again, we see this in our visualization. If I reset this, we know that we know that we're pushing A into Q2. So let me go ahead and just copy this. And the reason why is that we can just set this up for our next operations. Top. This will be pop. And then we've got our empty. And remember, we're going to be for top, pop, and empty. Once we swap all the items over in the correct order to the Q1, we're going to actually be using Q1 for all the proceeding operations or methods. So you won't see any kind of use of Q2 in here. Q2, sorry, it's just a temporary queue for us to make sure that we have the last added item at the top of our data structure, our stack. So what we're going to do is we're going to push to Q2, and then down here we're going to use destructuring to swap. So we're going to say this dot Q1, this dot Q2 is going to be this dot Q2 and this dot Q1. So we're using a destructuring shorthand method. This is just a very short way to say, we could do something like let.temp equals this dot Q1. And then we could say this dot Q2 equals this dot Q1. And then, so on and so forth. We would use a temporary variable to, swap those two queues. Sorry, this would be like Q1 equals Q2, and then Q2 equals Q or temp. But we've got our destruction here, so a lot more simple, easier to look at and write. Now, the one thing we need to do, now this is actually swapping things. So once we add an item, we swap it, which is this motion here. You can see it gets swapped. So it moves over to Q2. Now, the real magic of this entire implementation is this while loop here. So we're going to say while this dot Q1 dot length is greater than 0. So while there's elements inside of it, we're actually going to push back to Q2. So we're going to say this dot Q2 dot push this dot Q1 dot shift, and that's going to what's that going to do? Shift removes the first item from an array. So it's going to shift the first or remove the first item from the array, and it's going to push it into Q2. So we can see that here. We add another item. We see that, oh, okay, we've got an element. We've got something in Q1. Now watch, it's going to pop it from the top and it's going to push it into Q2. So now we've got sort of like the meat, the main portion of our push. And after that, we can now use Q1 because again, we've got our swap. So look at that, boom, that's the swap. And BA is now at the front. So these next methods become pretty simple. So for top, we're going to say, we're going to return this .q1 dot length. We want to check to see if it's 0, if there's nothing in the stack, well, we just return null. But if there's something there, then yeah, we're going to return this .q1 top. So in this case, that would be our B. And then let's go ahead and do pop. This would be this .q1 dot length, or sorry, yeah, is equal to 0. Again, we want to return null if there's nothing in there, we just return null. Otherwise, we can actually say this .q1 dot shift. That will return whatever's at the top. And then empty is probably the most simple. It's just this .q1 dot length, and that will return true or false. So let's go ahead and say stack equals new stack. And then we can, let's go ahead and add some items. Stack.add A. And we're going to add B. So at this point, let's say, okay, stack dot new terminal. Stack using queues. Let's see. Stack. Oops, sorry. We did not even call the method. All right, now we should get B. Oh, what am I doing here? Oops, sorry. Push. All right, B. Okay, cool. And then let's take a look at what is our next method, pop. This should give us, should return B since that's at the top. B, okay, cool. So it did pop that off. And then let's take a look at what is our next method? Pop, we did top, pop, and then empty will return false. False. And let's just see if we do this, we should see true. That's pretty much it. This is an easy question, pretty simple once you get the idea and the theory behind it, or the idea. But when I first saw this in an interview, I was not as familiar, so I probably didn't do that, well of a job. It can seem a little bit daunting if you're not familiar. The point I'm trying to make is that as you're studying for Leetcode in interviews, it's really good to just go over the basic data structures, like understanding string manipulation, how some strings are immutable in certain languages, arrays, their time and space complexity. Then moving on to stacks and queues would be a good area to cover. I'll probably do some videos on like stacks and queues and data structures. But for now, that's pretty much it. And yeah, that was a lot of fun. This is a question I like a lot. It's just a really good problem to have in your back pocket for an interview. And thank you so much for joining.